My name is Maciej Gruszka, and I work in Oracle development and in product management. I'm responsible for a few projects that we deliver today to the development community. I'm responsible for a team of product managers that are focused on outbound activities, so participation in the conferences, selling the products even internally to Oracle guys, promoting it among different potential consumers within and outside Oracle. And one of the projects that I will be talking today is a Verrazzano, is a enterprise container platform that we have built for a multi-cloud deployment of the applications in the cloud-native space. We hope the project is interesting, and we hope you will be able to take advantage if you look into that in your development project. So I will be briefly talking about the challenges with cloud-native development and cloud-native deployments. I will be briefly talking about Oracle implementation of the multi-cloud container platform. So what we would like to achieve with that project, what kind of ideas we had behind that project, and then I'd like to peel a little bit onion and look what's inside, tell you what kind of open source component we have used, how portable it is, what kind of technology we are using. And at the end, I have some short demo. And if you'd be interested, I will be able to share some links where you can find that demo or some live labs for you to test the Verrazzano. So cloud native is super trendy today. Whenever you go to the conference, usually you have a cloud-native day. Whenever you go to any kind of developer event, almost everybody talks about cloud-native, because everybody believes that following that pattern, that architectural trend, provides several benefits for customers or also for development companies. So architectures built with the cloud-native technologies are resilient by design, are very extensible, usually based on open source frameworks, based on open source technologies. So generally, development communities don't like to pay for the royalties for the licenses, and they don't like to stick into the particular technology. They want to keep more into technology that are rather open source and friendly. If they need to pay for something, they prefer payment for usage. So elastic pricing, pay as you go. The cloud bursting model of any kind of subscription-based pricing is something that is highly preferable. High automation of all technologies to ability to from source code to the deployment with plug-in to all those monitoring components automatically and directly executed is something that is preferred. Lowering time to market. Nowadays everybody looks that development projects need to be finished within weeks or days even from idea to delivery. Everybody talks about how to automate the process of development, how to even engage some kind of AI solutions to automate building projects, automate delivery of projects, and this trend of cloud native definitely follows that. Cloud native applications are scalable by design, horizontally scalable. It means every single microservice, whatever we call it, is able to scale automatically, plug, and expose its services to potential consumers. However, cloud-native technology also comes with a high demand for full end-to-end observability layer. So everybody who moves to cloud-native technology tries to check and achieve full observability. Why everybody talks about it, why there are many projects with moving to cloud native fails. If you look into the CNCF Foundation, today, if you go to the CNCF site, Cloud Native Computing Foundation, and you try to list different projects that's supposed to help you or to automate some different aspects of managing your Cloud Native projects, you get hundreds of different open source technologies, ability to choose and pick the right one with the proper version that are not conflicted to each other. It's a high challenge. It's a beauty, and also it's kind of mess at the other hand. So customers or developers or companies select and pick the most, I would say, typical ones. They usually don't drill into every single option because it's almost impossible really to make and rely on all those projects. So what's our vision? Our vision of delivery enterprise container platform for customers is to go and select and build like a curated platform which composes of the most typical CNCF projects, CNCF components, and deliver them as a single platform for customers. So instead of for customers to pick and choose a different component from different category, we want to make this journey for them. We want to offer them ability to pick up the most typical components that customers are choosing, the de facto standard. If someone goes into observability, probably picks 90% of cases Prometheus and Grafana. If someone goes to the service mesh layer, there are few possible options. The most typical is ISTO. If someone goes to looks for a solution in the infrastructure management, native underlying Kubernetes management, probably the most typical solution for that is going to be Rancher. So we don't want to make really rocket science. We want to really go through all that portfolio of different solutions, and in each and every category, select the most typical, the most accepted by community component, find if it fits together with other components, select versions that are fitting to each other, that are having comparable life cycle. Because another story is finding the right versions of those components that are having identical life cycle of patching. So in the moment that select, I don't know, Grafana, and the next Grafana major version is going to be in 2 months. But Istio is having the next major version in 8 months. So where should you make an upgrade? How to correlate those upgrades? How to correlate those patching? Would those versions would be able to run on the same Kubernetes version under the cover? It's a big challenge. It's a big challenge. This is the task that we decided to do ourselves, and our project Verrazzano is about to picking up and creating a curated platform of open source CNCF components that provides for customers the enterprise container platform. So Verrazzano is being offered and delivered together with 2 other components together. We try to Verrazzano as a platform itself is very Kubernetes agnostic, because what we need under the cover is just a Kubernetes platform that follows some standards and specification. Verrazzano itself can run on OKE, that you heard here 2 sessions ago, Oracle Managed Kubernetes platform, can run on third-party Kubernetes on third-party clouds, like on Amazon and Azure, can run on-prem. Many customers still are looking for a solution how to efficiently and effectively manage container-based applications for on-prem applications. For those customers, we try to provide, I would say, 2 extra components to fulfill a vision. We provide, OCNE. This is Oracle Container Native Environment. It is a Kubernetes implementation for on-prem customers who are looking to manage Kubernetes workload on their on-prem environments. OSCNE is an extension for Oracle Linux. So we are packaging it together like Verrazzano with Linux and with Verrazzano as a single hybrid cloud-native management platform for on-prem customers. However, if you look into the multi-cloud scenario, then you have on-prem, probably you have OCI and maybe third-party cloud together, and you want to manage the workload on all those three locations, then Verrazzano provides you like a single container management umbrella on top of those three and allow you to manage with a cross-cloud consistency the containers across those three locations. So let's go and check what's really Verrazzano is. If you look into Verrazzano, Verrazzano allows you first intelligently manage the workload. It means if you build a workload that composes of several containers, it consists of several containers, allows you to deploy these containers consistently and intelligently across the Kubernetes clusters and across Kubernetes nodes. So this is the first aspect of functionality of Verrazzano. Second is single application lifecycle management. Microservices applications, cloud-native applications, it is not like a one front end, one back end. That's usually multiple different front ends and several back-end applications, several second services applications, and each and every of them might potentially have a different life cycle, may scale up independently, may patch independently. However, still you need to have like a single umbrella to manage a single application lifecycle. If you want to have consistent operations like shut me down that entire portfolio of the application for my project, you need to know that someone is able to identify all those microservices and shut them down. If you say, scale me up that application, then someone must know what that application means, what services are included, which containers require scaling up, and which order. Also, if you say patch me the application or find me the newer version of containers and provide a rolling restarts of containers to apply patches, then someone must control that lifecycle of those containers. This is the role of Verrazzano. This is what Verrazzano does. So Verrazzano also provided automated built-in observability. Whatever application you deploy to Verrazzano, automatically all containers are plugged into the log management and into observability layer of Prometheus and Grafana. So you deploy Spring Boot application that is part of your, I would say, ecosystem of your containers. And that Spring Boot application automatically, whenever it's plugged into Verrazzano platform, will be automatically overwrapped with Istio mesh, will be automatically exposed to the Prometheus, and will start collect data for Prometheus on a config map, and will automatically be visible in the Grafana dashboard, and all log messages are gonna be captured by FluentD and pushed into the centralized log management of Verrazzano. You don't need to do anything in your code. You don't need to do anything in your, I would say, application as a developer. You build your application and the technology you like. You push it to the container management platform of Verrazzano, and Verrazzano takes care for automated built-in observability. Verrazzano also provides for you automated infrastructure management. So we manage not only from the app perspective, but also from the cluster perspective, your deployment location, and we provide a multi-level security. So what Verrazzano really is, it's a bunch of open source components that are enriched with several Oracle authored open source controllers and Oracle authored open source components that forms that platform of managing containers. So as a part of Verrazzano, we provide dedicated version of Rancher, dedicated version of Istio, Prometheus with Grafana, Argo CD for continuous deployment. We provide OpenSearch for log management. We provide FluentD for scrapping logs. We provide Jaeger. We provide Keycloak for single sign-on capability across your and security management across your applications. That platform allows you to run any type of application you like, starting from very traditional Oracle applications based on WebLogic and Coherence. We provide a tooling to convert WebLogic and Coherence applications to make them runnable within containers on top of Verrazzano. We provide a support for typical Java microservices. So we provide support for Spring Boot, for Micronaut, and for Helidon. We also provide support for any type of polyglot applications built within containers. So you want to run, I don't know, Ruby, PHP, Node.js application. You want to package them into containers, plug them into Verrazzano. Verrazzano will adopt it and will deploy it to the Kubernetes of your choice. So it will allow you to deploy to your private cloud, to your public cloud, runnable on OKE in Oracle OCI, or a third-party cloud with third-party Kubernetes. Verrazzano also allows you to design and build a multi-cluster configuration. So you may have one cluster runnable in OCI, one cluster runnable on-prem, and one cluster runnable on third-party cloud. And the workload is going to be distributed across those 3 locations, and you have a single pane of glass with Verrazzano to manage efficiently and effectively that workload across those environments. So this is what Verrazzano does. What we are using here is we are using some kind of standard for describing how applications should be attached to resources. We are using a specification developed by Microsoft together with Alibaba. It is called Open Application Model. Open Application Model allows you to, it's a community-driven standard that allows you to define like a decoupling of containers, how application consists of different containers and how these containers interact with each other and how they should be mapped to underlying resources. So whenever you take and describe your application with OAM, with Open Application Model, generally once you take and describe it, these are 2 YAML files that could be consolidated into the single one, and you pass it to Verrazzano, then Verrazzano creates for you security token, service account, all necessary Kubernetes artifacts to make all those containers running together on a different clusters, and also package them into the Istio. We'll put them automatically into Istio, and also will create a special connections to the Prometheus and special connection to the OpenSearch through FluentD for scraping logs. This is what automatically Verrazzano does whenever you deploy your container into that Kubernetes. So instead of taking pure naked Kubernetes, taking and defining different components from CNCF and making individual relationship between your applications and these containers and these applications, you may take a Verrazzano as a platform, and Verrazzano will do it for you. We do it in the single cluster model, so you can do it as a single cluster, and all those operators, controllers, and all those open source services are running together with an application. Or we support a model with a multi-cluster where we have a separated and dedicated admin cluster where we run, Prometheus, Grafana, all those dashboards, OpenSearch logs, and applications that are distributed across the managed Kubernetes clusters. These clusters could run within the same environment, so it would be like one OKE cluster, another OKE cluster, another OKE cluster, but they could be distributed geographically and even among the vendors. So it could be, I don't know, OKE cluster, on-premise OCNE cluster, and I don't know, Amazon EKS cluster, for example. For example. Yes, question? Can it run on the VirtualBox? Generally, running Kubernetes on VirtualBox is a challenge, but you may, I know that there are some stories where you can define Kubernetes inside VirtualBox. So answer would be yes. Okay, let's do maybe some demo. I have 9 more minutes. Okay, I hope demo gods are with me today. Okay, so I have built a very simple application that is like a microservice that is doing Hello World. This application is like, let's call it a few times. I hope it's still running. Yes, it's running. So I call it 1, 2, 3, 4 times. It displays a message. It is not encoded properly, so it was originally prepared as a REST application for REST APIs. It should be encoded. I have created on Oracle Cloud also, I'm using CI system on Oracle Cloud. So those of you who were on this here on the session about DevOps, you heard OCI is having its own CI server. So I'll be using CI systems to make some changes into the code. So let me do some changes. If I go to GitHub repository, and if I go to I will save it as a commit, and I will make this name like a level app demo. Okay, probably in a build server should start very soon. Yeah, 17 job is already in a queue. So in the meantime, let's go to our Verrazzano console. This is Verrazzano console. We are extending Rancher console. So those of you who are working with Rancher should know it. We are using exactly Rancher console with some extensions. So you can navigate and see what's going on here. There is a one local cluster. This is OKE cluster that is running here. And I have 3 nodes that are running on my OKE cluster. Default, I would say, implementation of managed Kubernetes on Oracle Cloud assumes 3 different availability domain, 1 node in every availability domain. I'm using that. You can navigate, you can manage it, monitor that. You can create cluster, scale up cluster through that console, and all these capabilities that you have to Rancher, Verrazzano offers you through that console. For example, you can go to Grafana. If we go to Grafana console, oops, I logged out. Of course, demo gods are not with me. So let me quickly So this is a Grafana console, but Grafana is provisioned out of the box. We provision several dashboards out of the box. We recognize what type of workload it is deployed, and we provision a particular dashboard per every workload. So because this is Helidon application, we create a Helidon workloads. Here, you're able to identify and find the Helidon monitoring dashboard. And there are several demos here. My Hello World application is this one. Hello Helidon application. Yeah, you can see that this is Helidon application has been executed several times in the last few seconds because I hit refresh on my Helidon application. Helidon, the Grafana uses and connects with underlying Prometheus layer. Prometheus is used as a persistent layer for all this monitoring information. You can go and monitor through Verrazzano. You can go and monitor through Verrazzano also Prometheus layer, Prometheus console. If I log there in, I hope I don't need to log into every console separately. Yeah, you can find, I don't know, vendor request. You can check, verify. There are several applications. If you'd find Hello World here, it would be probably easier. There are graphs for each and every of them. So Prometheus is pre-configured by default, and by default you can use it and navigate through Prometheus over your cloud-native applications. You don't need to make any extra connections. The same is with logging. We are using OpenSearch for scraping. We are using FluentD for scraping logs, and we are pushing it to the OpenSearch, and we are exposing the centralized log management of every and single applications through the OpenSearch dashboard. So if we go and find default, we create several default indexing filters that allows you to filter the log messages. Every single application is being visible as a Verrazzano application. And if we do filter with a hello, so these are calls that has been executed. So I have executed several times when I refresh just to populate the log messages. We also create everything that we deploy through Verrazzano is deployed under Istio service mesh. So you can go and navigate over Chiali console. You can see and check and visualize your Istio service mesh. You can monitor your service mesh through Chiali. So I will quickly go to graph and potentially show you how it looks like. That's out of the box. Application deployed to Verrazzano is automatically deployed to Istio under the cover, and all monitoring informations are visible. And the last one that I wanted to show is Argo. Argo is responsible in our platform for continuous delivery, as a continuous delivery software. We know that many customers are having own CI systems. Very often it is Jenkins. So at this moment we don't deliver as a part of the platform. But many of them looking for automation on the CD part, on the continuous deployment, and we are using Argo CD as a portable part of the platform. So if you select the application that I have configured here, you can see several, I would say, CD pipelines that has been executed. I think this one should be the one that has been executed 3 minutes ago. So our build server created for us new Docker image. Docker image with the new tag created new YAML file about this component. And Argo is using polling for that YAML file and deploying it to Verrazzano. So if we right now refresh the application, we should see right now that the hello world is right now with this label level up that we typed into our sources. So that shows you that CI/CD are also working on that DevOps platform. I have generally 2 more slides to show you before we finish. The first is about the resources. We are present in social media as a project. Verrazzano is by default is open source itself fully. there is no license, a commercial license attached. Anyone who wants to use Verrazzano feel free to use it. What we commercially offer to our enterprise customers is a support-only offer. So we offer in a model licenses and software for free, optional support available for commercial customers. We are present in the social media. Our website, verrazzano.io, lets you get access to the project itself. There is documentation. There are some videos there. The sources of Verrazzano are on GitHub. We are keeping entire project on the GitHub. You can ask for community support through GitHub as well. So we provide the support for customers that are not paying commercial support through GitHub issues. So you may raise issue. Of course, if you want to contribute to Verrazzano, we are even more happy if you provide to us contribution. We have our YouTube channel, and we also provide support for our early adopters through Slack. That's probably the most efficient way if you want to start working with Verrazzano and you are afraid, you don't know what to do. Go to that website. It will give you an access to our official support Slack channel, where you would have an access to our engineering team. Our engineers are super big fans of supporting customers and developers through the Slack. They are spending sometimes more time on Slack supporting guys than on executing real projects. So sometimes management is not so happy, but we like it a lot. And we enjoy our project a lot. That's why we do support that through the Slack as well. Access to the Slack channel is complimentary. Anyone who wants may have an access to that. My name is Maciej Gruszka. It was nice having you here on the presentation. I hope you enjoyed.